All right, now number 11. Okay, number 11, I'm just gonna be honest, is it's a little fucked. Okay, it's hard. Yeah, so you're in for a ride. They tell us that the strength of earthquakes is measured on the Richter magnitude scale with values typically between 0 and 8, where 8 is the most severe. The Gutenberg-Richter equation gives the average number of earthquakes per year, n. Okay, so what is n? N is average number of earthquakes per year is n, which have a magnitude of at least m. So m is going to be magnitude. Okay, for a particular region, the equation is blah. So this here is my equation. For some A symbol, big R. All right, what the hell is that? So when they say A symbol, okay, that symbol means that A is part of the following sets of numbers. R is going to be all real numbers. Okay, so all real numbers is going to be anything from negative infinity to positive infinity. Uh, Pretty much, okay? And it has to be divisible, a couple of other things. Yeah, but that's what it is, okay? The other things you can encounter is this weird symbol, which is like a very fancy Z that I don't think I even drew correctly, okay? Okay, that is for integers. See? Again, I'm just giving you context of what can show up. Integers is negative 1, 0, 1, 2. Okay, so whole numbers that include negatives. Natural numbers, which is just going to be like some fancy n, is going to be integers, but only the positive ones, okay? All right, so that was just a quick lesson on what that means. So a has to be a real number, okay? So it can be 0.4, it can be stuff like that, all right? Yeah, let's see what happens. This region has an average of 100 earthquakes per year with a magnitude of at least 3, and we need to find the value of a. All right, so the hard part here is really understanding what this formula is talking about, okay? Chances are most of you saw logs for just a little bit, okay? So if you ever face something like this in a test, whether it's a log or not, really think about the context and work with that, okay? So if they tell you that this region has an average of 100 earthquakes per year, which or do I have a variable that talks about average earthquakes per year? Yes, I highlighted it. And this is why it's important to highlight your buzzwords. Average number of earthquakes per year is going to be n. Okay, so this here is telling me that n is 100. The magnitude of at least 3. Did I talk about magnitude at some point? Yes, right here, buzzword. So magnitude is 3. Okay, now we're getting somewhere. See, even if you don't know what log does, now we're getting somewhere. Dale? So for part A, find the value of A. Alright, so um, my equation is log 10 base 10 big N equals A minus big M. So if I go ahead and plug all of that in, see, I will have that log 10 with N 100 equals A minus 3. Okay, now I'm getting somewhere, see? Now this on the left, again, it's part of understanding how a log works and everything, is an actual number, okay, that you can find from your calculator. You can actually go log, this number next to the 7, put 100, and there you go, it's 2. And now you might be thinking, okay, but this thing in your uh, calculator doesn't have the little 10. Okay, that's because the default is for there to be a 10 there, okay? That would be the base of the log. I don't want to get too much into logs because whatever, man. This isn't like a log problem, okay? It's just part of the equation. See? Plug in log 100. That is your thing on the left. This is 2. 2 equals a minus 3. Get a alone. Add 3 to both sides. A equals 5. Part A is that a equals 5. Okay, so then they tell us that the equation for this region can also be written as blah. N equals b divided by 10m. So, I already said that n is 100 and that m is 3. So let's figure that out. Okay, so n equals b divided by 10m to the power of m. So n is 100, which equals b divided by 10 to the power of 3. Okay, so even though this might look a little bit weird, you really gotta fall back on your principles of math. See? You wanna find b. You wanna get b alone. What is bothering b? B is being divided. It's being divided by 10 to the power of 3. So what do you do with 10 to the power of 3? You multiply by 10 to the power of 3. It's the inverse operation. What is bothering b? Something's being divided. What is the opposite of divide? You multiply. Okay, multiply by 10 over 3. Both sides. What does this do? Bada bim, bada boom. That goes away. I end up with b alone. B equals 10 to the power of 3 times 100. Alright, I can literally do that on my calculator. 10 to the power of 3 times 100 gives me a whole lot of zeros. 1, 2, 3, 4, 5. B equals 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5. It does look right to me. That is B. Cool. Okay. Not that hard, eh? I knew you could do this. Part C. Given that given that m is greater than 0 but less than 8, find a range for n. Alright, this is where some people get like a little tripped up. See? So, range, okay, is going to be lowest and highest possible value. Thus the name range. And my equation or my formula goes from a certain amount to a certain amount. So m can only go from 0 to 8. Okay? Alright, now we're getting somewhere. So if I go ahead and pull out my y equals and graph, ¿cierto? I'm going to be graphing the thing in red. I found out that b was 1,000. Okay? Sorry, 100,000. How many zeros is that? 1, 2, 3, 4, 5. Divided by 10 to the power of m. I can go ahead and graph this. See? Alright, obviously the first time you graph it's probably not going to look that pretty. I'm going to try zoom standard or zoom fit. Zoom fit. Okay, it looks a little better, so I'm getting there. In fact, that might be good enough. And so this thing, this thing looks like this, okay? And so over here in blue is going to be my 0. At some point, I'm just going to call here, it's going to be my 8, okay? So that means my range is going to be whatever this value is up until this value here, okay? That's going to be my range. So let's try and find it out. All right, what I suggest you do is that from here, you can actually pull out your table. So you can do second table or second graph to hit table. And here you can go from 0 until 8 and see what values you get. Okay? So that actually allows me to find these 2 points here. This point here, according to this thing, when x is 8, when x is 8, y is 1 divided by 1,000. And when x is 0, okay, we have that y is probably a very big number. 1, 2, 3, 4, 5. 5 zeros. So 1, 1, 2, 3, 4, 5. It's that number. See, 100,000. Okay, so that would be my range. It would be from here to here. That is my range. Now, of course, you need to write it in a more fancy way. You can say that my range for n goes from this to this. Okay, and if you draw the graph, you're going to get full credit. The more fancy way that I'm sure some of you are asking for, so 1 divided by 1,000, which is this guy here, okay, 1 divided by 1,000 is going to give you 0.001. So my n goes from here. Wait, I'm having trouble putting the symbol I'm trying to put. Oh no. Oh, give me 1 second. Apologies. Ah, there we go. Okay. So my n goes from that 0.001 up until 100,000. So that is another way you can write your answer. Okay. So that would be for part C. All right, and now for part D, they tell us that the expected length of time in years between earthquakes with a magnitude of at least m is 1 over n. Okay. Within this region, the most severe earthquake recorded had a magnitude of 7.2. Magnitude 7.2. All right, keep talking. For part D, we need to find the expected length of time between this earthquake and the next earthquake of at least this magnitude. At least this magnitude. Give your answer to the nearest year. Okay, cool. Interesting. So there's a lot of talk about at least this, at least this, at least this what? At least this magnitude. And so which magnitude are we talking about? We're talking about 7.2. So m is going to be 7.2. All right, so that's my first hint. The second hint is that once I'm able to plug in 1 over n, I will find the expected length of time in years, okay? Which is basically part D, see? So once I'm able to find n, once I find this n, I'm good to go, see? And so, n equals what? What tools do I have at my disposal? Well, over here that I'm going to now put in brown is an n equals. So n equals b divided by 10 over m. Do I have b? I do. Do I have m? I also do. So what is my n in this case? I will do it. I don't really have space. I'm going to do it up here. All right. So what is my n value? N equals b divided by 10 to the power of m. From before, we identified that b is 100,000. We said that m is 7.2. And so this gives me an n value of, just trust me on this one, okay? Plug it into your calculator, you end up with 0.0063095. Okay, that is my n value, see? Now, we said that for the expected length of time in years between earthquakes with a magnitude of at least m is 1 over n, see? So I need to plug in 1 over n. We just found out what n was. So 1 over n is going to be 1 over this big number. I plug all of this into my calculator and I end up with 10 to the power of 2.2. See? Your calculator might spit it a little bit different, so let me just show you what shows up. I'm going to put a fraction, 1 divided by 0.0063095. It gave me 158.49. Okay? So again, you can plug this in again. It's going to give you the same number. I just wanted to show it because some calculators give it differently. But there it is. Okay, it's basically the same number. You're good to go. This is basically 158, 3 significant figures, which is 158 what? 158 years. So that is for part D. I think the hardest part for part D is being very organized on the fact that you're trying to find 1 over n. See? This exercise spits a lot of information at you, and there's certain things you can't lose track of. Okay? I know there's a lot of words when it says at least this magnitude, expected length of time, blah blah blah. Okay, go for the important stuff. See? You read magnitude, you highlight magnitude. Where else does magnitude show up? Here, magnitude 7.2. Boom, m is 7.2. You work from there. You need to find n. What is n? Have I used n before? Here's a formula for n. Okay, that's the sort of thing you have to go for. Even if you don't know shit about logs, if you're organized in your approach and you think about what you need, what you have, and all that kind of stuff, that is how you can go through these problems. All right? So that is for number 11.